And welcome to the Daily Space Weather. We've got a coronal hole wind stream arriving a solid day late, later than NOAA's forecast at least. Let's take a look at the closest star. So here's one of our composite images. This is 193 and 131 angstroms. And if you've got a favorite composite type image, let us know what your favorite wavelengths are. And we're constantly doing this to show the most features and so on. These are both ionized iron ultraviolet emission spectra from the Solar Dynamics Observatory. We've got more for you too, and we're going to have a spectacular close-up at the end of this active region. This active region up here is not a sunspot. It is the most magnetically organized portion of the solar disk visible from Earth, but we see zero umbrae. We're expecting to see zero sunspots today. So here's a zoomed out view. This is ionized iron and ionized helium in 304 and 171 angstroms. And we'll get to that coronal hole wind stream data in a minute. Here's 171 angstroms alone, my personal favorite single wavelength. And my preferences are constantly changing on my favorite wavelengths as the features on the sun determine which are the best. Here's a star chart. If you're wondering about the path the sun will take across the sky today, we've drawn that in for you here. It's this yellow line. That is the ecliptic. And we're located here in Lehigh Valley, Pennsylvania. If you didn't watch yesterday's cosmology segment, make sure you check that out. We talked about this star right here, Betelgeuse, which is the largest single object visible to the naked eye, the red supergiant star. And if you're up before dawn, you may see Jupiter and Saturn and the moon out there. And here's a diagram of the solar system. It looks like we've got a new moon tomorrow. There's where things will be in 1 week on August 14th. The radio flux is, I think it's up to 74 now. And we'll get to the Space Weather Enthusiast dashboard. Yes, the upper chromosphere and lower corona produce radio flux. There's a radio signal that comes out of the sun, and the flux density of that is proportional to the sunspot number. As you can see here from the 1-year chart from Solon.info, this black line up here, this is the radio flux. And this is the sunspot number. The red line down here at the bottom. And the blue line is the post-dam AP, the planetary A index, the overall field in the solar system. And there you go, 74 solar flux units, basically solar minimum conditions here. We do see a strong field as well. We'll get to that in a minute. We'll look at the solar wind data. A strong negative Z component there. So NOAA was off by a solid day, although they did reforecast here for geomagnetic unrest. We haven't seen that kick in yet. We're just seeing the increase in the solar wind speed. We'll get to it in a minute. First, global seismicity. Current activity levels are moderate. That's a 90-day bar graph. And you can see that 8.2 happening south of Alaska there several days ago. What, about a week ago? A little over a week ago. So here's the list from USGS. And we'll just quickly scroll up here. Again, we have moderate levels here, so a few 5+ magnitude quakes, the largest being a 5.9 near the Antarctican tri-plate boundary there between the South Pacific, Antarctican, and South Atlantic plates. Some deep quakes as well, like a 5.0 at Vanuatu at nearly 200 kilometers depth. Philippines saw a deep quake at a 4.9 magnitude over 590 kilometers depth. That would be like a 6 magnitude if it occurred at the surface. Honduras saw a 4.8 at depth. There's that South Sandwich Islands quake that occurred at 1922 Universal Time yesterday on August 6th. Deep quake at Vanuatu, a 4.7 magnitude at 124 kilometers. Greece saw a 5.1. Leave us a comment if you're viewing from Europe. We've actually got quite a low number of European viewers. Also a 4.6 at Afghanistan. Also at depth, 111 kilometers, estimated depth of that. Did you know that volcanic eruptions can escalate and cascade into a global catastrophe? Well, it's true, folks. And there are various mechanisms by which this can happen. One of them is, of course, if a really huge volcano like a VEI 6 or 7 injects stratospheric aerosols and volcanic ash into the stratosphere, obviously, hence the term stratospheric. If that happens, it can cool down the Earth for years at a time, almost like a nuclear winter, making the planet cloudier, blocking sunlight, reflecting radiation, heat radiation, infrared spectra back into space. Another way a volcanic eruption can cause global catastrophe is by closing down something like perhaps the Suez Canal. Yes, the Suez Canal is pretty close to some volcanic activity, and that's one of the major things that could occur. A volcanic eruption could close down the Suez Canal. We saw one boat close it down for an extended period last year. Remember that? That was pretty interesting. Was it engineered? Was it on purpose? Leave us a comment. Let us know. Anyway, Cambridge study for existential risk have identified 7 pinch points. Relatively small volcanoes can cause a major beef, a major screw-up, a major failure of things like logistics, supply chains, financial systems, etc. And this is a SciTech Daily article. We were going to cover it yesterday, but there's too much stuff to cover. So Pinatubo did cause a global impact, estimated to be around $740 million if it occurred in today's dollars in 2021. So one of them is Taiwan, one of them is the Mediterranean, the Pacific coast, the Indonesian archipelago, the Luzon Strait in the South China Sea. It's time to change how we view extreme volcanic risk. We need to move away from thinking in terms of colossal eruptions destroying the world as portrayed in Hollywood films. The more probable scenarios involve lower magnitude eruptions interacting with our societal vulnerabilities and cascading us toward catastrophe, as if we haven't cascaded close enough already with COVIDiocy. So here's a list of volcanoes currently erupting. Fagradalsfjall now appearing on the list. Fagradalsfjall. Go ahead, say it aloud. Fagradalsfjall. It's fantastic. As a cinder cone has filled up its entire crater valley and become a shield volcano, as we documented it on the channel. Here's a 360-degree view from a drone, labeling all the locations. We just shared this on one of our Facebook pages. So join us on Facebook, facebook.com/smAshomash. That post should be going up shortly. Smash staff, if you remember, volcanodiscovery.com. And thanks, Smash staff, for all your hard work. Please give Smash staff a raise by becoming a patron or picking up some merch. You can find links at smashomash.com. Anyway, Fagradalsfjall not appearing on the list because of eruption. In particular, just appearing on the list because of this 3D panorama from a drone footage with annotations. Karimsky is erupting. On the Kamchatka Peninsula, it's producing a 7,000-foot ash plume. Abiko, 10,000-foot ash plume over Paramushir Island. Suwanosejima, 10,000-foot ash plume over the Ryukyu Islands near Japan. Semeru, producing a 14,000-foot plume of volcanic ash over Indonesia. Popocatépetl, or you may prefer to call it Popocatépetl, in central Mexico, 20,000-foot ash plume as it explodes. Popocatépetl on my bucket list, by the way. Folks, we hope Mexico becomes a non-banana republic one of these days. Also the U.S. Sangay exploding, producing a 20,000-foot ash plume over Revenador, and another ash plume over that country, as Revenador also explodes, 14,000-foot ash plume over that caldera. Sabancaya exploding. Intermittent emissions have produced a 24,000-foot plume of volcanic ash. Please do not attempt to do the Fosbury flop over the caldera. Congratulations to our U.S. field athlete winning the gold medal in the pole vault. And we're unable to detect whether or not Nevados de Chilean is erupting. Please do not take that as a cue to attempt to pole vault the caldera. It could be unhealthful, and this public service message brought to you at massive personal risk and expense from smashomash.com. Next, looking at the GOES X-ray flux here, the sun-facing suite of instruments on the GOES 16 showing us no major solar flares, and we're not expecting any as we see no sunspots. No spikes in the proton flux either. No coronal mass ejections have struck, and we're not surprised. We would have probably forecasted it. And here's the GOES magnetometer, and we're seeing some very low readings and then some spikes. There's a coronal hole wind stream just arriving, and we can expect this to last for, I'll say, 18 hours as We saw a dud for the first coronal hole wind stream. It's like a double pulse. And we've also seen a delay in the arrival of the heliospheric current sheet of northward polarity. So we actually forecasted this, and we're going to see the North Pole current sheet hanging out there. The Earth will be in the South Pole current sheet still tomorrow. So this current sheet shown here in red is South Pole. This one up here is North Pole. And that North Pole current sheet is going to be delayed. I won't get into the physics of it. I'll just move on, as that was what we call a forecast. Here's a line-of-sight view of the same data here, a three-dimensional line-of-sight view from our perspective instead of the top view like this, showing us the shape of the current sheet. And again, that North Pole green current sheet is going to be delayed for the near future. Next, the line-of-sight coronal hole plot. Give that a minute to load. There we go. And you can see those South Pole-oriented coronal holes. Also a North Pole-oriented coronal hole making its way down toward the equator, as we see cycle 25 really delayed here in its progression of the solar polar field reversal cycle. Probably an indication lots of intercalate gases are building up in the lattice layers of places like the photosphere. But we won't get in depth into that either. It's the daily space weather. The sun's B field also shown here in blue. Those blue lines, those are the sun's B field. Next, we've got solar flare monitor and detected coronal holes, and you can see actually 3 of them showing up here periodically. I believe those are all South Pole oriented. Those indeed are South Pole oriented coronal holes, all of them. And this one up here not yet showing up on this computer detection process. Solar flare probability quite low. Again, no sunspots. We see 0 umbrae on the Earth-facing portion of the solar disk. Global geomagnetism currently calm. We can expect this to come up a little bit, possibly making it into geomagnetic unrest or minor storm conditions. So we'll keep an eye on that. And when I say eye on, the pun's intentional. Let's look at the real-time solar wind. And we've seen this uptick. So yesterday we saw a small, tiny little, barely noticeable uptick in the solar wind speed. We saw this little uptick in the density, and then a downtick in the density and an uptick in the speed. Solar wind speed only got to 333 kilometers per second yesterday, and then it came back down as if the coronal hole wind stream had ended. However, it's not. There's a second pulse. So the density went back up to 18 this time, and now we've seen a little bit bigger increase in the solar wind speed. Current conditions are about 12.3 protons per cubic centimeter for solar wind density, solar wind velocity 409 kilometers per second. We also see a strong BZ here. So this red line is the BZ. That is the orientation to one of the poles of the solar magnetism. The BT is the total field. And when you see a negative BZ component, that is an indication that in other words, that induces greater amount of geomagnetism than a neutral BZ. In other words, if you saw 9 and 0 for those numbers, or if you saw 9 and positive 6, that would be less geo-effective than that negative BZ, although it is looking like it's converging here back toward the 0 line for that Z component. Next, 4 hours of pressure data, and we see pretty high pressure here. And this is 4 hours of data from University of Michigan. It's the space weather modeling framework, so really the data is interpolated into this model. It's the space weather modeling framework. If you want to read about how the model's derived, it's got lots of variables in it. Just go to the Geospace Magnetosphere Movies page, click on Details, and you'll have a link to the space weather modeling framework. Homogeneous pressure over the past 4 hours. And somebody who's taking off homogeneous pressure is our patrons. So thanks for increasing the probability these videos will continue to exist, patrons. And if you like the content, please consider becoming a patron. We're paid just this side of nothing to make the videos on YouTube. So that's why we picked up Patreon in the first place. Patreon.com/smAsho. You get all kinds of behind-the-scenes stuff, early reports, early warnings, etc. Patreon.com/smAsho. Thanks again, patrons. Here are ground magnetic perturbations looking at the Earth's own B field. The last frame was Geospace Magnetosphere Movies. That was in nanopascals magnetohydrodynamic pressure. Now we're looking at the magnetic flux itself on the surface. Geospace delta B is changes to the Earth's B field. We showed you the sun's. Here are changes to the Earth's. And we see this increasing here toward the end of the video. Maybe we'll see the solar wind speed go higher. We'll have to just watch it because, frankly, we don't know what'll happen. NOAA was off by about a full 24 hours as far as this one goes, though. We saw a very weak pulse yesterday, and so the main coronal hole wind stream apparently arriving today. By the way, congratulations on realizing that our channel exists. If you've got ideas for our 2,000 subscriber special, let us know in the comments. We'll be doing that soon. And don't forget to press like and subscribe if you enjoy the content. Tell your friends and foes, science noobs and science pros about the channel. We're also on BitChute, although most of our content is indeed on YouTube. It's very feature-rich. And today's cosmology segment is integrated into the daily space weather video. Let's do it. The astronomy picture of the day is a 3D image of the Jezero crater on Mars. I don't own any 3D glasses, and I don't care about this, but if you do, go to apod.nasa.gov, and you'll be able to look at this great view here of some rocks on the surface of Mars. Pretty sweet. By the way, we've beefed up smashomash.com/forum. We've got links to the YouTube page at the bottom. You can click on smAsho Mission if you want to read about what our mission is. By the way, we intend to be in this part of the thing. We intend to be good and fast, but not cheap. It's part of my background, folks. smashomash.com/forum. You can find a link to that on the homepage. Smashomash.org will relocate you here. You can find our social media there. Also the Smash merch link. Don't forget to check that out. smAsho merch. Here is a quick view of the merch shop, at least one of the products. Since making Earth not suck again is up to you, shop our 55 products with this fantastic high-res logo. Mensa, make Earth not suck again. It's up to you, not to bureaucracies, since bureaucracies have identified themselves as the problem in the year 2020. We're the solution, they're the problem. Are you familiar with Cygnus X3? It's coming out of its X-ray quiescent state, and those arrows coincide with the same part of in other words, the current emissions are way down there, and we're hoping radio astronomers will check this out before it goes back into an X-ray loud state. We want to see the transitional state in radio frequency. That's today's cosmology segment. Cygnus X3 featured. If you want to read more about Cygnus X3, head to smashomash.com/forum. In the cosmology forum, there's an entire thread about it, which is multiple pages in length. Continuing on. And we've got some minor charging hazards here for satellites caused by electron flux, and there you can see over places like Mexico and the North Central Pacific. Some minor charging hazards there, nothing major. Here's the 1-year chart of the relativistic electrons surrounding planet Earth. This is measured at the F ionosphere layer, by the way, by the GOES-16. The GOES-16 is in geosynchronous orbit, but it measures the electron flux at around 300 kilometers of altitude. We'll show you the ionosphere momentarily in vibrational graphic form. Here is the 3-day chart of the electron flux, and as we forecasted yesterday, you can see this cratered with the arrival of the coronal hole wind streams. So there are 2 perfect examples of the electron flux cratering, possibly as a result of the coronal hole wind stream, but I'll just say associated with, because we don't necessarily understand causation. It all comes down to how we're measuring and what we're measuring and so on. So here you can see we're going to be correct that we forecasted dips in the electron flux. This is the forecast model. The green boxes are the forecast. The yellow diamonds are the observation. Here's a diagram of Earth Van Allen belts. Normally it has 2 sets. During serious geomagnetic storms, we do sometimes get a 3rd set of Van Allen belts out there. And anyway, that's a diagram of that. Here's a total electron content forecast showing you electron density. And we see some anomalies here once again south of Africa and south of the Atlantic Ocean. Are those electrons coming out of the Earth, going into the Earth? Are they from the sun? Where are they from? What's up with those electrons? If you've got a theory, let us know in the comments. We'll let this play through a second time. Those anomalies occurred around 1600 yesterday. 1600 Universal Time. We saw some chaotic and anomalous electron flux around Antarctica. Here's a diagram of the atmosphere. Feel free to pause the video if you must. Now we're showing the ionosphere located at about 300 kilometers of altitude. And we'll have to reload these. I apologize. There we go. So the FI ionosphere layer is located at about 300 kilometers of altitude, and here it is in vibrational frequency. Each blob of color here represents 1 megahertz, 1 million vibrations per second. There's a lot of chemical reactions and other stuff going on at the bridge between Earth and space. We cover it daily on the Daily Space Weather. Let's bring up the latest image here, as we do regularly. That's from 11 o'clock Universal Time. Things looking pretty normal at that moment. Here's the anomaly animation, and this is showing you anomaly in megahertz. If it's to the red, it's anomalously low. If it's to the blue, it's anomalously high. And what can you say? Lots of anomalies associated with the South Atlantic anomaly, which maybe should be renamed the South American anomaly since it's now over the center of the continent, having moved from the Atlantic Ocean over the continent. And you can see right where it is. It's very obvious in the ionosphere anomaly map right there. You can see anomalies on both sides of it. The weakest point in the Earth's magnetosphere. Here's the latest image from that. 11 o'clock, things looking fairly normal at that moment. The most significant anomalies are low levels of vibrational frequency in the southern Indian Ocean. By the way, we do meteorology segments regularly. We'll be doing another one today. It'll be a separate video. If you didn't watch it, it premiered before the Daily Space Weather. Make sure you check that out. You can find all of our at youtube.com/smashamash/playlists. All right, and we've recorded another great meteorology segment. Again, make sure you check that out. Here come bonus features. So here's the latest ground-based observatory data from El Teide, Spain. To show you 0 sunspots, we've got some prominences and so on. This active region here, again, it wasn't a sunspot when we did show prep. Let's see if it's showing up as one now. First, the GOES 16 SUVI imagery. There was a minor coronal mass ejection and a filament collapse. It was too minor to really even cover. And you can see some pink here. There is some additional X-ray, it looks like, coming out of that active region. Let's see if it's a sunspot. So that's what I saw when we did show prep. And again, no umbre. So prime example of an active region not showing up as a sunspot. It could be forming an umbra there, but it certainly doesn't have any at the moment. Here's the full disk view. Again, no dark spots, no sunspots. We've got some spectacular imagery to close things out, as we've got an active region setting in the southwest as well as in the northeast. There's a close-up of that. Splentacular imagery here in 304 and 171 angstroms from the Solar Dynamics Observatory. And we'll close out today's daily space weather on this active region. Check out the close-up. It's fantastic. Almost as fantastic as you, the viewer, tuning into our videos. So thanks again for watching. Remember to tell your friends and foes, science noobs and science pros, about the channel. Lots of changes coming, especially in the month of September. Visit our links, support the channel, and may that solar wind be at your back.